So now we are online. You will be able to see if somebody is watching us. You can also share the YouTube channel, URL among your friends, the circles. I will do it immediately. Okay, so welcome all of you for our session on digital manufacturing. In fact, this is kind of a historical event because it's the first time in Sri Lankan context. I think it's also one of us in South Asia to talk about 3D printing or digital manufacturing as an online discussion. This is a discussion among experts. We have particularly one speaker, but also all of you are joining here are actually expert of different field, mainly in manufacturing and digital technology. So welcome you all. What we are going to do is very quickly we will have a introduction among yourself, and then I will introduce our main speaker. He will be talking for around about 40 minutes, and then we'll have about 1 hour Q&A. Now, during that time also you can have interactive session through our the session in terms of chatting. I'd like to start from Ajanta to introduce. By the way, my name is Chaminda Hettiarachchi. I am the CEO and Managing Director of Digital Consultancy Private Limited. It's a consultancy based in Sri Lanka. We are trying to introduce new technology and do management consultancy as well as internationalization of higher education. Now, this is kind of experiment for us to engage in this new venture of digital technology. So I welcome you all again, and I would like you to introduce yourself very quickly. Your name, where do you, if you work somewhere, or your profession, and maybe your interest in digital manufacturing, or if you have any expertise, you can very quickly share with maybe 1 or 2 minutes. We start with Ajanta. We don't hear you, Ajanta. Maybe your mic doesn't work. Then you unmuted your mic. You muted, now unmute, but we don't hear. Ajanta, till you fix your mic, or you can type and then start with Chintaka.
Hello, yes, hope you can hear me all there.
Yeah. Go ahead.
Yeah, I'm Chintaka Jayanand. I'm joining here. Yeah, I'm Chintaka Jayanand. I'm joining today from Scotland. Currently, I'm reading for my PhD at the University of Betty Dundee in Scotland. And, well, that's about me for now, I think, briefly.
Yes, Greshen, very quickly. We'll have a separate introduction to Greshen, but you can introduce and say hi.
Yes, so I'm Greshan Fernando, and I'll be very brief because Chaminda is going to introduce my profile. So maybe you can hear about that, and then also I'll be speaking, so we can talk later. So let's move to the other person.
Yeah. And also, it's good if you tell where you are joining from.
Oh, yeah. So I'm from, right now I'm in Seattle, Washington, the USA.
Yes, Malmi. Malmi, your mic is mute.
Yeah, okay. Can everyone hear me? Okay,
yes.
Hi everyone. So this is Malmi Amudur, and I'm joining from Sri Lanka. And I'm currently reading for my master's degree at University of Moratuwa, Sri Lanka, and I'm currently a senior software engineer at Australian-based company Geo Australasia. That's all from me.
Okay, thank you, Malmi. Prasad, unmute your mic.
Yes, Chaminda. I'm hear you, but I have some problems because some noise here. So I have to mute my mic. But all of you are here. I'm Prasad from Sri Lanka. I'm journalist. So I would like to join in your discussion.
Okay, thank you very much. Mala baat kala? Mala. unmute your mic.
Yes, I hope you can hear me now.
Yeah.
Yes, I'm Priyanth Palavat from joining from Colombo. I'm the Chief Executive Officer of George Stewart Optimus, and my background is basically ERP. So that's about myself. Cheers.
Yeah, thank you, Priyanta. Tilan? Tilan, unmute, please.
Hi everyone. Hi everyone. Hope everyone can hear me. I'm Thilan Jayatilaka, joining from Sri Lanka. Currently working as a manager IT at Good Hope Asia, providing state-of-the-art IT solutions to meet with the business requirement. And recently I've completed my MBA. I think that's about me.
Okay, thank you, Tilan. We miss other Tilan. Unmute.
Hi everyone. So I'm joining from Maldives. I'm working as a corporate head of IT in Adaran group of companies in Maldives. So my background is I'm a professional engineer and we're currently reading the MBA at University of Moratuwa. So that's all about me.
Okay, thank you, Tilan. Umali?
Yeah. Hi everyone. I can hear me, right? So
Yeah.
Ali Colombo, MBA at the University of Moratuwa, and I'm working at Etisalat, Sri Lanka as application support executive, and my background is ERP. Thank you.
Okay, thank you very much, Umali. Now, shall we try with Ajanta again? Ajanta, can you try? I think your mic doesn't work. So this is a problem with not trying before. Maybe you can type later when the session is going on. Okay. So we have very diversified in terms of expertise, in terms of location, and also in other professional background. But also you can see that all of us are sharing kind of similar interest of digital manufacturing and also innovations in technology. So with that background, I think it's a very good mixture of experts here. Now you may be already knowing that this is live on telecasted live on YouTube. So we already have one viewer. I'm sure this will be viewed by other people and also people who can they can also watch this later. So I want to introduce our main speaker today, Mr. Dr. Greshan Fernando. Now, Greshan is a special person because due to different reasons, now he has been in the US more than I think 15 years, but he is interested in sharing his expertise to among Sri Lankans and also to actively engage in Sri Lanka in terms of transfer of technology and to different projects. In the other specialties, now we have been in the university and the same batch for 4 years from 91 to 95. So this is the first time we actually officially connect for some professional reason. So this is really interesting. Now, also Greshen has a very interesting professional background. Now he and a technical leader in the well-known Boeing company. His expertise are product lifecycle management, computer designing and manufacturing, CAD/CAM, and system engineering. He has also worked with most diversified group of people and smart people at Boeing. From 2008, patient has been living in Seattle. Also now, not in addition that he is also having his own company, consultancy company called Green Power Systems or GPS, where he work with energy and water engineering solution for sustainable future. Uh, G GPS has consulted different organizations, including governments of United States, Vietnam, Indonesia, Brazil, uh, Cambodia for last 5 years. Now, before joining Boeing, Greshan has mainly worked as an academic he has been assistant professor in engineering and industrial technology from 2002 to 2007 at West Virginia University Institute of Technology on CAD/CAM control systems and design and robotics. In Sri Lanka, Greshan did his engineering degree from University of Peradeniya in production engineering, and he moved to after graduation in 1995. He moved to US in 1997. I think he's one of us from our batch to go to US for his postgraduate studies. He did master's degree in mechanical engineering from University of Ohio, and then he has done different research, particularly with the US Air Force, and then he did his PhD also in industrial and mechanical engineering at Ohio University. Now, all along in academic career, he has been, in higher education faculty, in engineering, in industry, and also business owner. Now, Greshan has been very proactive in keeping up with technological changes and new technological trends that can help society in a positive manner. Now, even though he has been working in different business entities, but he has always been interested in helping or contributing or using technology for social development, such as the venture we are trying to do now. His keen attention in the technological affairs has made him think and study about recent developments in digital manufacturing, which is considered as the next industrial revolution that can change the society and way of life for better. He is interested and has a vision to utilize the digital manufacturing technology within the context of social movement, where people can make almost everything for local consumption. You will hear some of these examples today. Today he is going to talk about how digital manufacturing, which people call as a third industrial revolution, and how to use it for the benefit of Sri Lanka. I think this is a very interesting timing, because now we are talking about all these hubs in Sri Lankan context, and we see a lot of developments happening. At least the policy makers and the political leaders are talking about different innovations. But how to do this? Now, this is another solution. It's a suggestion how you use the development in digital manufacturing, how that can be used for nation building of Sri Lanka in post-war situation. So he's going to talk about that. So welcome, Greshan, and floor is yours now. You have about 40 minutes to do your presentation.
Well, thank you very much for the wonderful introduction. And yes, Chaminda said, I had to leave Sri Lanka because especially to get rid of Chaminda, because he was my roommate for 6 years in Peradeniya. So, I wanted to get rid of him, in fact, in Sri Lanka. So that's one reason to leave Sri Lanka. Those who have associated Chaminda know very, very fun person to be around. And I always enjoy talking with him and hanging out with him, and wonderful person, and one of the best persons I have associated in my life. So, having said that,
can you speak a little bit louder?
Yeah,
if you don't mind.
So,
thank you.
Having said that, thank you to all of you for joining today. And I think this may be a very important discussion, and maybe a first step to come up with some sort of plan to spark interest on the new trends in manufacturing. Hold on a second.
Okay. Meantime, now if you have any questions, you can actually have a chat here, and also you can share the links or whatever along with our chat line. And all the time, please keep your microphone mute. I will make also Ajanta. I will mute him because I can't anyway hear him. So okay, you can also mute yourself. Okay, go ahead.
Yeah. So first, so let me get to the presentation first, and then we'll discuss about I would like to hear your opinions and ideas about the ideas that I have. So first, let me get to the presentation. Then
but you gotta speak a little bit louder. Not clear. I mean, you're clear, but for the recording for other people to watch, it should be more audible. So speak a little bit louder.
Okay. So, yeah. So I'll try to be loud as much as possible.
Yes.
So I'm getting closer to the microphone as well. So first, let me get to the presentation here, and I'm going to share my screen presentation, and then we'll walk through that. And feel free to interrupt me anytime while I'm talking. And it's better when you ask questions. That way, we can build up on my discussion or the presentation here. So first, let me get the screen shared. So can you see my screen now?
Yes.
Okay, good.
Yeah, we can see.
So okay, great. Is there anybody who cannot see it? I hope everybody can see. Okay. So first, let me tell you that why I got interested in this new manufacturing revolution. After joining Boeing about 4 years ago, well, actually not more than that, but after joining Boeing, I had I learned a lot of things, and then I thought that we can start a car manufacturing, company in Sri Lanka. So I was planning for that, and then so while I was thinking about that and doing planning myself, in fact, I stumbled upon one economist special report, which said a third industrial revolution is shaping up, and that was on this.
Yeah. Can you make your screen full screen or bigger? Dilan, Jatra suggest please control and L full screen, control plus L, or maybe you can screen make it bigger. He's using Apple, so that's the problem.
Yeah, I'm using a MacBook.
Yeah, make it a little bit bigger.
Yeah, I can. Then that will go out.
It's too much.
Yeah.
Yeah, it's bigger, too big. That's now better. Now better. Yeah, this is better.
Better. Okay.
Now it disappeared.
It disappeared?
Yeah, I see you now.
See it now? Okay.
No,
you see me
now
or
we see you?
Oh, okay. Hold on a second.
Share it again.
Right. And it share it again. Hold on, I'm going to share it again.
Now other people, if you want screen, you just click that person. I suggest you keep Greshen as in the main screen, but if you want to see another person in large scale, you click that screen. Okay, now we see the screen, okay, but you can make it still bigger for full screen. Control plus L doesn't work for you, huh?
No, it doesn't work in Apple.
Okay.
So if I put let me see this. Let me do this.
This is okay. I think
now?
You can go. Yeah, this is okay. Can be bigger, but it's all right.
So no difference. No difference from what I did, right?
No, not really. But it's okay. Go ahead.
Okay. Well, at the end, I can send this presentation to everybody as well, so that you can read later on as well. Now, so anyway, what I was talking about is how I got interested in this digital manufacturing revolution. So I said that there was an economist special report on this one about a year ago, and so I read that, and then I was kind of I had like a paradigm shift. I mean, I was thinking, earlier I was thinking of building an electric car in Sri Lanka. And then with this one, I thought, okay, we can use this technology for the social benefit in Sri Lanka. In other words, we can leverage this technology to produce almost anything in Sri Lanka. And this picture itself, tells you that you can do many things from your home. This is again the picture that I extracted from that Economist article. So as you see, you're producing things, including you see an aircraft, which is a very big thing to produce. We are not there yet, of course. We cannot print an airplane yet, but there are project initiatives in the US and also in Europe to do those. So it is getting very excited, and it's at this level, at this point, or in other words, today, the technology is just like it's not actually at the early stages, but it has come a long way. But still, there's a long way to go, at least for another 10 to 20 years. In another 10 to 20 years, I would say in 20 years, we will be able to print entire cars or entire airplanes sometimes using the technology, using this digital manufacturing technology. So now, before first let me talk about some historical perspectives in terms of industrial revolutions. As you know, we had the first industrial revolution that started in Britain. In the 1700s, and it started with the mechanization of the textile industry. Like the large textile mills were born, or in other words, we say the factory was born in that era during the 18th century. And then there was a second industrial revolution at the early 20th century, where Henry Ford mastered the moving assembly line and ushered the era of mass production that we know today. So with that, we had these expansion of railroads, development of steel and oil industries, and there was a communication revolution, and then the advances, great advances in transportation. Those are the good things, and also there were like bad things that came along with like the very difficult conditions for the industrial workers, and also there were massive profits for business tycoons that created a income disparity between within the society. And then there were a lot of good things and bad things that came along with these first and second industrial revolutions. And then this slide shows a comparison of first and second industrial revolutions. So basically, in terms of energy, first industrial revolution, the main energy source was coal, and then in the second industrial revolution, it was petroleum and hydroelectric power. Now, as we know today, the coal and petroleum are the biggest culprits for the global warming. So these industrial revolutions have introduced massive new problems that threaten our world today. So although we had a lot of positive impacts to the society from these revolutions, similar to those positive impacts, we have experienced great challenges that came along with that. And also, as I said earlier, the first two industrial revolutions made a group of people richer, and also, group of people became more urban, as we know today. So we have a very, rich group of people today, like business tycoons, and then we have very poor majority of people today that work for these business tycoons or big companies. Now, with the third industrial revolution that I'm going to talk about next, I think we may be able to find solutions for some of these problems in the future. So, do you guys have anything to add on what I just said? These are some historical perspectives that I wanted to start with. I would like to hear any thoughts on what I just said, if there is any. But you don't have to, but I'm just asking. All right.
I think they already studied this, so you can go ahead.
Sure. Yeah. Thanks. Okay, and then after these two industrial revolutions, there came a digital revolution that we all know very well today. In fact, most of the participants are here in this discussion know very well about this digital revolution, so I don't have to talk especially on this one. And in fact, we have this Google Hangout session thanks to this digital revolution. And now this digital revolution marked the beginning of the information age, of course, and then that created some new opportunities. And in fact, the next industrial revolution was facilitated by this digital revolution. So as an advancement of that digital revolution, this third industrial revolution is underway. That is, the manufacturing is going digital. So with the digital revolution, we had enormous progress, of course, and the focus of discussion is not to talk about those things like internet and cell phones and everything that we enjoy. And as you know, all these revolutions were disruptive. Changed the society. Change the society in positive ways and also in negative ways. And so, like all those revolutions, this third industrial revolution will also be disruptive, and it may be disruptive than the previous revolutions. As that is a prediction. We don't know where we will be heading. But some of the changes that we can see in the future is like the current supply chains may be obsolete. Like we may not need these existing supply chains in the future. And then the large factories may no longer be required in the future, and that will result in in the future there may be some mass layoffs that will impact the society, and so on. So we can talk about those changes in great detail. But again, I'm just providing some perspectives on this coming up digital manufacturing revolution. So this third industrial revolution, or in other words, digital manufacturing technology. Yes. Mm-hmm.
Sorry to interrupt you at this moment.
Sure, no, go ahead.
Yeah, I have a doubt. That's clear that using digital manufacturing with the help of high performance computing, we can digitally manufacture something. But how about the kernel of that product? Like kernel in a sense, the systems and how that will be produced. Is it also part of this digital manufacturing? I mean the kernel, the.
So when you say kernel, the entire system.
Yeah, entire system. For an example, such as like when you take an object that is that digitally that with the help of computer aided design or something like that, we can get an object. But how about the system that the internal?
The system that makes the object, you mean?
No, not that. The engine and the which you record to function it. Just take a car.
Oh, okay, yeah. So
An object.
I see what you mean. Yeah.
Digitally, that
Right.
with the help of computer aided design or something like that, we can get an object. But how about the system that the internal system that makes the object? No, not that.
So
The engine and the which you require to function it. Just take a car.
right. So I understand your question now. So let me briefly explain. So already it has been proven that we can directly print functional assemblies. So you're talking about like if you're printing something like an engine, how it can function, right?
Exactly.
Because there are a lot of moving parts in an engine, and so it has been proven that we can do that, and there are they haven't printed an engine yet, but there, I have seen working like functional assemblies that were directly printed out in one shot from a 3D printer. But these are not very big ones, like small scale ones, like for example, toy cars. You can the toy cars can be printed in one shot that has wheels that will rotate. So you can you can push the car and it will function as expected. And as I said, there are I mean, we are still at an early stage, but it has been proven that functional assemblies can be printed in a single shot from a 3D printer. In fact, very recently, this is not a good one, but very recently they printed a functional gun out of a 3D printer, and they fired the shots, and then they banned it in the US because it's very dangerous. So those are of course negative one, but it was a single shot print handgun that was done. I mean, that was produced using a 3D printer. So we can print functional assemblies, or in other words, entire systems, as you just said. I mean, your question was how a system can work. But what I can say is we can make very large systems in the future that will be functioning as any other assembled system today. So, I mean, we have to go a long way for that, but things can change quite rapidly in the coming years. Yeah, I mean,
Can I raise the question?
You are not audible enough.
Can I raise the question?
Maybe a little bit later because we will have 1 hour for Q&A.
Okay.
Yeah, we'll let him finish. Greshan, are you there? We can't hear you. Your voice is very low. Tilan, he can't see you. You're chatting because he's sharing the screen, so he can't see the chat box.
Okay. Thank you very much, Greshan. I think I got the answer.
Yeah, I will get
It's
back.
clear.
We will get back to that in the Q&A. Um, now let
Can't
me.
hear you properly.
I think I am speaking very loudly, but I think there may be some
Now, okay.
bandwidth problems from your end. In fact, I have a very high bandwidth here as well. I'm very fast internet connection, and I'm speaking very loudly. And I think there are these are some technical issues. So I'm trying to speak as loud as possible. Okay. All right.
Fine. Go ahead.
So okay. So the again, going back to the previous slide, I just mentioned about the third industrial revolution. Now, when you think about Sri Lanka, we did not gain much from any of these industrial revolutions. Like the first industrial revolution didn't much do in Sri Lanka, and we did not get many benefits out of that, and then we did not get much out of it out of the second one either. And in fact, from the digital revolution also, we did not get much, although India has gained some benefits out of the digital revolution that started in 1950s. So my hope is that we can leverage this third industrial revolution to the benefit of the Sri Lankan society, and we will get to that again at the end. All right, so the digital manufacturing is also known as, we have various other names like 3D printing, additive layer manufacturing. In the past, this was called rapid prototyping, but now actually today it has gone beyond rapid prototyping. So rapid prototyping means like before you produce something, you make a model out of the product to just see and feel and touch and see how it looks like. So today the digital manufacturing or 3D printing has gone beyond rapid prototyping, but that is again still the name is still there. And then also it is called stereolithography. So it is one of the technical terms that is used. That is in fact one of the technology that is used for 3D printing. And also it is called cloning designs. Like if you have some object, like let's say you have a very valuable historical artifact in a museum or something, and if you want to recreate that, we can scan it and get a 3D CAD model of that, and then we can print it out. So that's why that means it's like cloning that historical artifact, or we are recreating that historical artifact or any object we can recreate. So that's the cloning. And there may be several other terms, loosely used that means the same thing. So I'm going to go through some brief technology overview. So digital manufacturing, it consists of a class of technologies that can directly construct physical objects from a computer-aided design files. So as some of these I mentioned earlier, so this digital manufacturing could trigger innovation worldwide and provide opportunities for everybody towards prosperity. And it could greatly improve product accuracy, and it could eliminate the mistakes that we do today in product development. And most importantly, we can customize the products with greater flexibility, and also we can have something called personal fabrication. That means we can make things for our consumption as we wish, and it will accelerate time to produce, and it will reduce product cost and improve collaboration globally. And that means we can share our designs globally, and then you can make things locally. And it could save this planet and save your life one day. So again, I will show you some example towards that direction. Now I'm going to show you a YouTube video now on the things that I just discussed. So let's watch that, and then it's about 7 minutes video, and after that again let's get back to the presentation. Chaminda, how are we doing with the time? Hello.
We are okay with time. I mean, we are ahead with time, but that's all right because we can recover later. So you can go and
Okay. So I'm
show
going
the
to
video.
I'm going to open a video here.
Now, Palapatpal is asking the question: when you say the supply chain will go obsolete, I want to know where the raw material is going to be to printer concept of new raw material. I think you will explain it later.
I will explain it later. It's a very good question, and I appreciate that question. In fact, I wanted to discuss that later on.
Now, if you have not you have the YouTube app, you won't be able to see the videos. I think all of you have, so therefore it will be okay. Greshen, are you all right? Greshen, what's happening? I can't see actually.
Other items that have been 3D printed.
Can you see
trend is set to
Can you see the
continue.
video?
Today,
Yes,
I can't.
printers can build.
Chintaka can see. Yeah, okay.
Hold on. Okay, I stopped the video. Can you?
Yes.
Who couldn't?
Yeah, I can't see, but some people can see. I think it will take time based on bandwidth. So you can continue.
Okay, so I'm going to play again.
Yeah.
Okay, so that's the video. So I think some of you did not see this. I mean, could not see it, maybe due to some bandwidth issues or some other issues. So I have shared this already, so you can watch it later. And also, I will be sending my PowerPoint presentation that has the link to the presentation. So later, maybe you can watch again. But now, as you saw, we can basically design anything and then manufacture it directly using if you have a 3D printer. There are companies in the US today and also in Europe that I hear a dog. So okay.
Yeah, they are my dogs. Don't worry, I'll mute it again.
Okay, so there are companies in the US today where they have a lot of 3D printers, and we can design anything that we want, and then we can send it to them, and they will print it and ship it to me. For I have to pay for that, of course, but there are companies that provide that service, and it's getting more increase. And at Boeing company here, we have an initiative to get rid of some of the spare parts for the airplanes. Like in the future, we will not be providing spare parts to the airline customers. Instead, we'll be providing the design to the customers, and then the customers can print the part themselves by using their 3D printer, or they can have another company to do the printing for them. So that's one direction we are headed. Not only Boeing, a lot of manufacturing companies are, making plans for that in the future. Now, at the end of the video, it said that it will not replace the traditional manufacturing. That is true in the short term, but when you think about the long term, like another 20 years or so, it can replace the traditional manufacturing completely. And there are some research going on in at MIT and also some other institutions towards that direction. Okay, so I'm going to continue with the presentation. So let's get back to the presentation. So I'm going to share my presentation again and then move on.
You have to finish by 20 minutes.
Okay, so let me
Okay, you see the screen.
Right. Okay, so now this picture shows some commercially available 3D printers today. Now, this stereolithography, laser sintering, fuse deposition, and 3D printing itself. Now, these are different technologies that have been used in the 3D printing. So 3D printing itself is considered as a different technology because that is that name came from MIT when they created something called Z printer. But all these names are again 3D printing. So as I said earlier, these names are used very loosely today. Now these machines range from like 10,000 to sometimes $500,000 today. Some of these fuse deposition machines are very expensive, and also laser sintering machines are very expensive today. But there are 3D printers that we can buy from Amazon.com today, and that you can buy it for like $500 or sometimes $1,000, and they can produce parts using plastics only, and also they have a small build volume. Now the machines that you see here are like commercial grade ones that we have some of these at Boeing. Unfortunately, I don't use these machines at Boeing. I'm not directly working on the 3D manufacturing at Boeing, but I have seen this in operation at Boeing. Now, this is a functional assembly, as you see here. That this was printed as a single step, single shot from a 3D printer called Z printer from Zcope. Zcope is now called 3D Systems today in the US. Now these are like printed using powder material. So this is just for like a prototype only, but it's a functional thing. You know, these parts move and it functions as expected, but it cannot carry any loads in this particular one. So it's not very strong, but this was done about 4 years back by Zico. So this is, as I said earlier, for one of the questions you had, so they have built functional assemblies. And then this is another, again, 3D printer that can print in different colors. So this is one of the objects that has been printed by using the machine that I showed earlier. And it has like rubber-like flexible parts and different colors. And this is a functional system. The toy, this is a toy car, of course, but it works. You know, you can pull it and push it, and the wheels will rotate, and doors will open, and the hood can be opened up just like in a normal car. So it's a completely functional system. Again, these are, I'll walk through these quickly. These are like very big machines, commercial grade machines that have been used by big companies like Boeing, Airbus, and GE, and so on. This is again the selective laser sintering is another manufacturing. Now, if you guys are interested in these different technologies on 3D printing, we can have a different discussion. So I'm not going to go into details on this and just providing some available commercially available machines here. This is another one, and this is again another one, and then this is a list of 3D printer manufacturers. Like 3D Systems is one of the major ones here, and then Stratus, and then there are some good ones in Europe as well. And again, these are so I have used the one in the left here when I was at West Virginia University teaching. So we had one of these machines that can build plastic parts. So we did quite interesting stuff using that machine about 5 years ago. So now let's look at some of the applications today. Now this is an application at Boeing. So we use we produce 3D printed parts to check whether, like, especially like for rapid prototyping today. So to make sure that the concept will work, and then like testing and assembly for a modification process. And even today, like KC-47 tanker means it's a Boeing aircraft being built for the United States Air Force for refueling the aircrafts in the sky. It's a big airplane that will carry a large amount of fuel to the skies and refuel the other airplanes in a combat operation. So they use a lot of rapid prototyping using 3D printed parts in developing that aircraft today. And again, this is the same thing. Like different parts are being prototyped and tested before they are being manufactured today. Again, this like scaled models for like visual reference and to show it to customers and for customer approval and concept buy-off. This is the picture you see is a 3D printed scaled model of a 747-8 aircraft. And then in the architecture, we can have like after designing the building, we can have a replica of that building that can be 3D printed, and that way you can visualize it. And it's been used widely in architecture today in the US. we can touch and feel and see before the building is being built. And then we can do crazy things like this. Like a watch like this will be very expensive to manufacture with the traditional manufacturing technologies, but with the 3D printer, we can make this very easily once you design it, of course. The manufacturing complexities can be removed with the technology. That's one major advantage. And again, these turbine blades are very complicated to manufacture using traditional manufacturing techniques, but these are being done with the 3D printers with ease today. And again, so new products like this, like very light, these are very light bicycles. So people do a lot of different new innovations using the technology. And so they can come up with new ideas and produce their, they can make their idea a reality at a very shorter time with the technology. And this shoe that has been printed using a 3D printer. And again, this is a designer shoe that has been directly printed from a 3D printer. After designing in a computer, and you can directly print. So the fashion industry has utilized the technology today. As you see, this is again some fun stuff like bikinis and stuff are also designed and manufactured directly using 3D printing. So not only small stuff, of course. Now they have printed houses using the same technology, and so they have built big houses, in fact, using the technology. So when you build the houses, it's called contour crafting today. And actually, University of Southern California has a big research going on in this area. And there's a video that I have linked here, but I'm not going to show it here. We can see it later when I send you the presentation, and I'll also share that in the Google Hangout as well later on. But it will show you the building has been built using a 3D printer, a big house actually. And the important thing is that the entire house was built within 24 hours. So it's remarkable, of course. And the house included all the electrical work and also plumbing, not just the walls and roof. It includes all the systems in it, that is plumbing and electrical systems and so on. So it's a functional house, of course, and it's a large, that's the large scale manufacturing using the same technology, of course. And this website that you see here, the URL, that will link to the University of Southern California, the project site on that particular building construction using the 3D printing. And then this picture, it's called Ubi. It's the first 3D printed car, and the entire body of this car has been 3D printed. When I say entire body, it's like the doors and the glasses and lights, except the engine. Engine was not 3D printed, but everything else was 3D printed, and all are functional. Like you can open the doors, you can open the windows and close them, and so on. So it's a 3D printed car which has great aerodynamic capabilities to reduce the fuel consumption. And they are planning to drive this car from East Coast to West Coast in the United States, which is going to be about 5,000 miles. And they are going to do it in using just 9 gallons of petrol. 5,000 miles from using 9 gallons. So they have designed the car in such a way that it gets greater fuel economy. And in fact, the engine is going to be a hybrid engine, of course. But it's a very lightweight, and these shapes can be achieved this greater flexibility of the 3D printing. And as I said again, it's a functional system, functional structure that works. again, this shows some other, like the cars, and then the buildings, and then the like a drones, and then the gear wheel system. Like actually, it's a clock that you see on the right hand side, and then as I showed earlier, like the clothes or clothes can also be manufactured, and then historical artifacts and so on. Again, I have linked this one to another website that will provide you more details. So when I send the presentation, you can again read on that later on. And then again, there are a lot of applications in dental science and also in medicine, of course. So the tooth can be manufactured using 3D printing very easily. And the things like this, like the the skull with a see-through material that can be produced in a single shot using this. And again, this is again a similar one. There's a sorry, I hear some noises. Is there a problem or hello? Chaminda, is there a problem?
Go ahead. No.
Okay. And then this is a front jaw that was used in a transplant that was 3D printed. So this is a medicine application that the 3D printed jaw was made out of titanium powder in a 3D printer. So again, this is a physician who is using 3D printed skull parts in an Army Medical Center in Washington D.C. And these will be implanted to the patients so that they can save the lives of wounded soldiers. And this is why I said the technology could save your life as well. And then they have these 3D printed hearts, and then like when you have a burnt skin from a fire or something, then the skin can be 3D printed directly to your body. So the machine that you see on the top can be used to directly print your skin using stem cells. You can print the skin directly to your your body, and then that way you can repair the skin within a very short time. And this is another biomedical application of the 3D printing, where they print human organs like kidneys and livers. That the technology is the same, but the material is the tissue cells, and in other words, the stem cells. So the stem cells are deposited in an organized manner, layer by layer, to produce the functional organs today. And there are several companies that are doing this in the US today. It has greater potential. They have printed human tissues, and they have not directly used those organs in the patients yet, but that can happen in the near future, in another 4 or 5 years from now. And then again, it can be used in a lot of fancy stuff, like producing different shapes of chocolate and a lot of other food items, of course. So that's another area. So the applications are enormous. Again, this is I'll skip this. These are dental applications, of course, and these are like unmanned drones that are 3D printed. Again, the jewelries with a lot of complexities. Like when you see a jewelry like this, it's very difficult to manufacture. Although you can design it, very difficult to manufacture using the traditional methods. And with the 3D printing, it's very easy to produce once you design it. Again, I showed a similar example for the shoes. Again, you can come up with any complexity, and it's not an issue for the 3D printing. Again, this is a functional robot that was 3D printed. Again, a shoe, and then this is a helmet that was 3D printed. that was printed using temperature-resistant plastic using a machine produced by 3D Systems. And this is a vacuum cleaner that was 3D printed using a machine from 3D Systems. And again, all sort of things like this is a rollerblades that are 3D printed in different colors, and it's functional, of course. It was done by using a machine called Object, again from 3D Systems. And then this is a big thing. This is not done today, but using 3D printing technology, British Airbus engineers aim to print out an entire aircraft wing. And this was they initiated this in 2011. They haven't done it, but they are planning to do it in the next 10 years to build the entire wing using the 3D printing technology. And then since Airbus initiated it, so Boeing also copied it. So they have the Boeing also has an initiative to print the entire aircraft wing using the 3D printing in the next 10 years. So if you can print an airplane, what can't you print? That was from the new article, of course. All right, now I'm going to shift the talk a little bit here. There's a center at MIT called Center for Bits and Atoms. That center does a lot of interdisciplinary research exploring the boundary between computer science and physical science. So CBA, or the Center for Bits and Atoms, studies how to turn data into things and things into data. So that means, now this is where I said, somebody asked the question earlier, like, what about raw materials that are being used in the 3D printers today? Yes, today we do need the raw materials, of course. And if I send a 3D printer to Sri Lanka today, I have to send the materials to Sri Lanka as well. So there's a supply chain for the 3D for the material. But now this CBA is looking for ways to print things using any materials to get any properties that you want. So you can use any material, and then you change the molecular structure of the material, and then you print. When you print, you change the molecular structure so that you can get the required properties. So that they have done some research, and these are not commercially available, but we are heading towards that direction, so that we can use locally available materials to make things with the properties that we need. So that means we change the material, or in other words, as the MIT professor, his name is Neil Gershenberg. So Neil Gershenberg says that we can program the material the way we want. The way we want means to have the properties that we need, the strength that we need. So with that, we don't have to transport materials from one place to another. We can use the locally available materials and make the things we want. So the only thing we need is the design that can be shared globally through our existing digital technology. Now, this CBA's work is shared through outreach programs, including a global network of field fab labs. So that's the term that they use, called fab labs. These fab labs, or in other words, fabrication labs, provide widespread access to prototype tools that can be used for personal fabrication locally. So they provide these equipments as a community outreach project that they are conducting since 2006, as I remember. And so they have created like nearly 200 fabrication labs worldwide. There are some in India and Pakistan and Afghanistan, and then also many in the Europe and Africa, and also in the US, and also in South America. So the next slide is actually, again, I'm going to show another video on that fabrication lab concept. And in the video we have, it's a CNN video that Professor Neil Gershenberg has been interviewed by the Farid Zakaria in CNN. So let's watch that. That's again about 5 to 7 minutes, and then after that, I think I'm close to the end. So I think we're doing okay with the timing. So let's watch that first, and then let's get back to this presentation again. So let me get back here.
So you can go to the YouTube app now.
Yeah.
We actually finished the time, but we can give another 5 to 10 minutes. We'll be finished by 12 or 11:30, between 11:30 to 12 Sri Lankan time. Another 45 minutes maybe, or 1 hour maximum. Okay, YouTube time.
Hold on a second. Yeah, I need to get.
Yeah, watching.
This one.
3D printing revolution?
No, not that.
Okay.
Give me a second. Okay, so I can you hear me now?
Yes.
Okay, so I think some of you could not see it, but again, I'll share it. I think I shared it, or if not, I'll share it. And also, the link is there in the presentation, so you can watch it later. So let me, as you saw in the video, so he's talking about something called digital materials. Those are like zeros and one in today's digital technology, where you can use 0 and 1 to do anything. To do the entire, the digital technology works with the zeros and one. And similar to that, we have something called digital materials that they are developing, and that can be used to make anything basically virtually. And as he said, the technology is still not there, but he's talking about 15 to 20 years ahead, and that's where the manufacturing become completely local. All right, now let's go to the next slide. And can you see my presentation on the screen?
Yeah, MIT Center.
Okay, yeah.
You have 5 minutes only, huh? You have to finish by 5 minutes now.
Yeah, I'm there actually. So, hold on a second. Okay. So this is the video we watched. Now, this is the concept of Fab Lab that MIT has, and they have established about 200 labs worldwide. You saw it in the video as well. And the Fab Labs, as as you mentioned, they cost about $40,000 to $50,000. Like, if there is somebody who can make that money available, then we can set up one. So my idea was to set up one of those in Sri Lanka, and then I'm willing to contribute some money towards that. So the equipment contains like laser cutters, 3D printers, and a lot of other high-tech manufacturing equipment that can be used to make anything in the lab. So and that these Fab Labs can do a lot of things. Like, it can be used for education and then sparking innovation, leadership development, and so on. So there are a lot of possibilities if you have one like that anywhere in the world. So in fact, they do have a lot of these created around the world. So my idea is to have one in Sri Lanka as well. And so that's why I asked Chaminda when I visited Sri Lanka last January that let's think about this and then try to plan for that and have one lab created in Sri Lanka. Hold on a second. Another half an hour also. Please go close the door. Close the door. Recording? Yeah. Close the door, please. Okay. Sorry, I was interrupted. So so that's my idea. Now this now I know that we have to have some sustainable models if you're doing a Fab Lab like that. So there are various models like we can create one with the money that we provide from here, and then but we need to be able to have personnel to operate it, like manage it, and then we can have like a we can charge an hourly access, but I don't like to do that personally. But then we can use it for personal production and generate money, and then we can have we can use it for education, like provide workshops, training, and even some degree certification for the companies. And basically, we can sell the education using the Fab Lab, and it can work as an enabler for products and services to other companies, and then can use as a mechanism for invention, like new business creation and individual entrepreneurs and joint ventures and so on. And then it can network with you know, a lot of other organizations and institutions within Sri Lanka and in fact worldwide. So those are some sustainable models that we can think of now. Now these are still you know, we have to think about these and plan. There's a lot of things to do before we start one. But my main objective today was to spark interest towards that direction. So with that, that's the end. And so now we are open for the questions and answer session. And let me close the presentation, and then let's get back to the video here.
Okay, thank you very much. I think it's good time for you to switch on your videos so we can see people still they are awake. We can see who are awake and who are not. And
okay.
Greshen, you want to say something else?
No, I just said yeah, I'm back on the video.
Okay, great. So I think we can now open like questions without any restriction. So you can ask clarification questions, or you can add something. You can you know, make contributions, or you can make suggestions. Like we can have once like a round for clarifications and more you know inquiries. Maybe you start from Buddhika.
Hi, can you hear me?
Yes.
Okay, just briefly, it's a little bit about myself because I was not in the beginning of the presentation. So I too graduated from Peradenian, and I obtained my MSc and PhD in Singapore, especially in MSc was in computer integrated manufacturing and PhD in nanotechnology. So right now I am working in Georgia Institute of Technology, and it's so it's a great presentation, and I would like to ask few questions on how we can make use of this new technology in Sri Lanka. So it's like, so basically we know that apparel is one of the main industries in Sri Lanka, also jewelry as well as agriculture. So I would like to ask from Greshan that do you have any idea, or do you have any plan, or what do you think about these industries? So who should initiate this 3D printing kind of technology, or who should I mean, how we are going to start this new technology transfer in Sri Lanka?
Yeah, that's a good question. In fact, so I exactly don't know what are the best products to start with. That the people in Sri Lanka may have a better idea than that than me today. Because I have been out of Sri Lanka for the last 17 years now. So, so I think the products that can be easily marketed in Sri Lanka, like you said, textiles, and there may be other ones, like for example, CFL, or not CFL, the LED lights, for example. It is not easy to produce in Sri Lanka. They produce in Sri Lanka today, but I think those are not very high quality. So we can produce high quality LED lights, for example. This is just one thought. And then, there may be other possibilities, but so I would like to contribute from the from our folks in Sri Lanka to explore on that question further.
Anybody want to answer that or make some suggestions where you think it's relevant if you can use in Sri Lankan context?
I can add something like can all hear me, right?
Yeah.
Then I also a bit interested about the agriculture. So and I would like to ask from Mr. Greshan that if now when we go for a tea or rubber industry, if it's a rubber can we print? I mean, from that thing, for we have that all things facilitated here in Sri Lanka. We can have the base, and also in earlier also I typed a question that what would be the raw materials for those things. Then as he explained that those things can be generic, so I would like to get more details about that. Is the question clear?
You are dropping off. Like I did not hear everything you said. So when I heard that agriculture. So when you say agriculture, are you talking about the agricultural machinery or any particular agricultural or any like for the agriculture we need a lot of machinery. So we can plan to produce that. But I think that's what we can produce is the secondary thing. We can decide on that in the next another session like this. I think at this point I mainly would like to discuss the like if we are going to have a fabrication lab like the one that I mentioned in Sri Lanka, what are the main challenges that we have? Let's say we have the money to do that. So that obstacle is not there. But let's say we got the money and we can have the equipment required for the fabrication lab. But then still there are a lot of great main challenges to do that in Sri Lanka. One thing is like finding a place, and then another thing is like who will manage it, and then who will be involved in training people and educating the community about the product and marketing the lab, and there are a lot of things that we have run this as a big project. So I think at this point those are the things that I if you don't mind, that's what I think. So and if we have a plan that we can establish in Sri Lanka, and after that we can think of what can be produced. That I think we need to include how we can sustain. Like once we establish the lab, we need to be able to self-sustain that. We cannot send money from US or any other country all the time to keep it alive. So it should self-sustain. That's one major thing I think we need to discuss and think about. Maybe not in this one, but in another session. But I would like to direct questions towards that, or in other words, if you have questions on like somebody asked about the material. So today we have to send the material from here, or some materials may be available there, but mainly for the 3D printers today they have like print cartridges, which are kind of expensive today. So that will continue for some time. But then with the new research coming up, we should be able to utilize more local materials in the future, and then, so we should have some leaders over in Sri Lanka who can take us in that direction as well. So there are we have to plan for different aspects and how to operate the lab in different directions.
Yeah, there are questions. I think Priyanta is asking about the raw material. Priyanta, you want to repeat the question?
Yeah. Can you hear me first?
Yes.
Yeah. My question is now, you say that the raw material properties are also being designed currently. But you see, currently, I mean, sorry, in future it will be designed, but currently they have to be fed in, right?
Yes.
Now, what are these materials? Then, I mean, are they being fed in like the way you fed in materials to a machine, or I mean, how does the printer work, basically?
Okay. So if you're using a 3D printer today, the machine manufacturer provides the material cartridges. So we have to purchase the cartridges from the manufacturer. So it's like print cartridges for the normal printers. Like similar to ink cartridges, we have to purchase the material cartridges from the manufacturer today. Now, going back to the fabrication lab that I mentioned, in a fabrication lab, the machine that we have will not just only the 3D printers. There will be other traditional high-tech equipment like three-dimensional CNC machines and laser cutters, water jet cutters, and so on. So those machines um, are not exactly 3D printers. But the concept of the fabrication lab is not just using 3D printers, and 3D printers will also be there, but use those high-tech traditional manufacturing machines in the lab, and then we can produce, with those machines plus 3D printers, we can plan to produce anything that we need in Sri Lanka and that are good for the local market. That's what the fabrication lab is. Otherwise, it's not just a lab that has only 3D printers.
Also, when you say this initial investment is around 40 to 50,000 rupees,
Right.
Sorry, it's dollars, right?
Yeah,
Then
dollars.
what does that consist of? I mean, is it just the basic printers, or is it like the infrastructure required to set up a lab like this, or what exactly is the cost consist of?
The cost is for the equipment, like as I said, laser cutters and CNC machines and water jet cutters and then 3D printers and also some material for those 3D printers and also computers to operate. All those machines will be controlled by the computers, of course. So computers and so on. The cost, the 40 to 50,000 cost, does not include the infrastructure in Sri Lanka. That means the building, or providing other like facilities like electricity and water and other infrastructure facilities at the building are not included in that cost.
There is also, is there anything to do with process planning? Is it relevant here? Process planning. Is it?
Process planning, yeah, of course. There are a lot. I mean, anything is a process. So setting up the fab lab itself is a process. So we have to plan for that, and then once you have the lab, then everything will be done with the process. We will have multiple processes to do anything.
So design.
Everything.
Sorry. The engineering design, the manufacturing process plan within the design itself. Is it? You have the design of the object itself, the engineering design.
Yeah.
Then you have the process of manufacturing.
Yeah. So the manufacturing process plan is that can be done using the computer. Like there are a lot of tools today to develop the process plans. We do it using the software. And I think you're talking about like if you are going to make something using a CNC machine, there is the process plan we need to execute to produce that. So those so those things should be done. Of course, that's a part of engineering. But that can we can have people trained to do that. It's like similar to design. You have to once you have a design, then you have to have a process plan to manufacture it, right? And then with the process plan, then you execute the process plan and generate the CNC code or the CNC program to manufacture it. That's the traditional CNC programming. And then so when we are using a 3D printer, again, there's a process to follow, of course. That's not exactly the same process
Okay.
that we
Yeah, I think that's a different kind of question from Tilan. Maybe Tilan can add on that. Now, the idea is that this T3 printing or digital manufacturing is the entire new ecosystem. So just without thinking about only the product or the industry we will be serving, you have to look at the entire system. How, with whom, how, what is the motive for example? Can it be a profit venture? Can it be a social enterprise? So, and then how you organize maybe I think you were talking about Fab Lab as not really as a like a profit based enterprise. So now, if we want to start something in Sri Lankan context, so what are the the indicator? What are the ways, for example, we should think? Now you already mentioned, but I think we have to focus on that. Now, if you won't really do, I think one of the objectives of the discussion today, not really only that, but think about if we are going to do this as a project. So what are the dimensions we can think? Maybe next time we can discuss about that as a separate discussion. But can you kind of elaborate on that?
Yeah. So I don't want this to be a profit or making an enterprise like a limited liability company or something like that. Not that. My object is to be a social enterprise. That means we provide services to the society in Sri Lanka. But we need to be able to sustain. The people who are working in that should be compensated, of course, for that. And otherwise, they will not be able to live in Sri Lanka. So like any social entrepreneurship here in the world today, we should have some mechanism to generate revenue by performing operations in the lab, and there will be people running it. But then we provide greater services to the society by operating it. So my idea is like, so we will have initial funding, let's say, and then we have some other issues, of course, we need to talk about. But let's say we establish it, and after that, to sustain it, we pick some products initially to supply to the Sri Lankan market. I mean, we basically sell it. The idea is selling it and then generate revenue to sustain. I mean, to pay the salaries for the people who are there, and buy raw materials and maintain the facilities. Operational costs, pay electricity bills, pay water bills, and so on. So there are a lot of things.
Actually, I'm Tilan. My question is now, if you are like say set up a kind of a lab or something, so we must give a value proposition to the end customers. Even for the social service, we must provide the value proposition. Otherwise, anyway, it will not be a sustainable thing. Of course, then if you think on that lines, I mean, people, processes, and methods, technology, and everything, like say the data, especially data, where we want to cater and which part of the segment we want to cater, those are the important things, I guess, because of course technology already almost proven, but everybody know about the technology of 3D printing and using of digital manufacturing. What I am trying to like say tell you is like say we must show the value of doing this, and we must show the value proposition. Otherwise, it's very difficult to like say sustain, or like say we have to, very difficult to go as it is.
Right. So so let's say we have a sustainable model that we produce things that can be sold in Sri Lanka, and at the same time the social the social service will be like training people towards that, to use this technology. That should be free, of course. And by doing that, we can get free labor to produce things as well. Because they come and they contribute towards the things that we are making. Just like the current graduate student model in Sri Lanka. Sorry, in USA and in Europe, where you get the cheap graduate students here, and then you teach them, but you get a lot of work out of them. A similar model where they learn and also contribute to sustain that social enterprise. And by doing that, they learn a great deal, and then some people can become great inventors, and then if they want, once they learn the skills, and they can have their own company outside of that. That's fine. And so, and then some may become educators to others, and then they can have a different income stream by teaching these. So if somebody is using the lab for income generation purpose, then we will charge, of course.
Yeah.
Right. We can have that in the model. But if somebody is coming to learn for himself, then it's free. But then he has to contribute towards its functions. And that's where we can spread the technology. And so when I say spread the technology, it's not just for engineers; it's for everybody. And there are things that that everybody can do in a fabrication lab, not just engineers, not just IT professionals. We do need engineers, we do need IT professionals, and we do need everybody. So I think the social model should be that, and then we have to have that income generation mechanism by selecting a particular industry or particular product. That has to that should be the value proposition that Ilan just mentioned.
That's right. Yeah, I agree with you, Greshan. Now, if you take, like, say, be competitive in this, like, say, this world, or in Sri Lanka, even in the manufacturing segment, be competitive. Let's say go to the this manufacturing. Digital manufacturing is the best option because it can increase your productivity while reducing the cost. And so then the industry will come to you and ask, like, say, you have to give or consult some services for them to be improved. So that's what I'm trying to, like, say, emphasis on this, because they must looking for a value from us, even not we are not.
Yeah, the industries in Sri Lanka, the companies, big companies and small companies, they may need the services towards from technology, and we can provide that. That will be a charged service, of course, not free for them, because they are income generation institutions, and when we provide a service to them, then it will be a charged service.
I want to ask something now. Actually, this is from Chintaka. Now, we saw yours in the CNN video. There are some issues faced by American companies in terms of printing pistols. Now, there will be a lot of regulatory issues, social issues, even religious issues.
Yes.
Now, of course, there will be capacities of doing things which will not be, for example, accepted by the society. Now, Chintak was talking about negative aspect of second industrial revolution. So now, can you explain on what are the issues we will have, or what are the kind of negative aspects?
Negative aspects. One will be like the one major thing, especially this is very important in the US, and it will be important in Sri Lanka too. One thing is, like, when we buy something when we buy something today, we expect it to have a great, we have some expectations. We have to have a quality product, and it should be safe to use, and should function the way we need, and so on. So there are many things that when we buy something, if it doesn't work and if it has a safety hazard, then there are issues, and we, in the US, we will sue the company who produces it. But now with this one, we are producing it. I mean, the producer and the consumer is the same. So now who takes the responsibility? And so one major concern is we need to have very strict processes that we need to discipline people to follow the process, so that we can make a safe product. That's one thing. And then the other issue would be making like dangerous stuff like guns, or in other words, you know, the dangerous tools like the one you saw. And then the other negative aspects may be like the environmental. Today the 3D printing parts cannot be recycled easily. So there are some environmental footprint, but they are actually working on that. Especially with the digital materials, we will be able to recycle. Like we can create the product and recycle it very easily in the future. But today, that's another concern. Like the environmental impacts are also there from this one. But I think those environmental impacts outweigh the benefits, because we can produce things with less energy and less. I wouldn't say always less energy, but in some cases, again, less effort at least. So in some cases, if the part is a very complex one, it will be less energy as well. Because today, if you are going to use the traditional techniques to produce a complicated part, it takes a lot of energy to produce that. But with the 3D printing, we can save a lot of energy in that side. So the main negative ones I see is we need to take some individual responsibility in producing things. And so we have to have some disciplinary issues in Sri Lanka, mainly. In disciplining people to follow the strict process requirements for the safety of the people. There may be other issues, but that's one thing I was thinking of. So any other questions?
Yeah, I have something to ask. When I saw these, all these products have been produced by the machines. Let's say, for simple example, you said the cars are being produced now by these machines. So there will be no these assembling plants anymore. That will all be transferred to the machine. So what will happen to the people who are doing these things today? So what do you think about them, their future?
Yeah, that's why I said this technology, as it progresses, it will be disruptive to the current way of life. It will be destructive in positive and negative ways, both ways. The negative way will be like there may be, even today we have seen this in the US. We have an employment issue now because of these technologies. Like I mentioned earlier that Boeing is planning to have a supply chain of spare parts. And they're going to digitize it mainly. That means they will not be producing any parts, but then have the designs available to the customers in the future. Not very near, but in 5 to 10 years' time. So that means everybody who is in that particular spare part supply chain, they will lose jobs, and those implications are there. But now, if we have socially organized at a local level with fabrication labs like these, then we have to change our way of life, and not just going to a big company to work for, but we work for ourselves, for a community, and but still we can produce everything we need at the end. Then we are fine, and so we will be able to sustain, and if we do the right thing. But we don't know how it will move on in the future. Yeah, there will be disruptive negative aspects from the technology, just like from any other technology. The second industrial revolution, somebody had asked negative things from the second industrial revolution. So one main negative thing is the mass amount of pollution. They use this petroleum products vastly due to the second industrial revolution, and it has threatened the world now, and still they cannot stop it. because they have to run these factories and power everything with the fossil fuels, and so it's a big issue that came along with the second industrial revolution. And then there's this income disparity that has resulted in this segregated society today, including America, mainly in America, in fact. So we have a lot of issues with the income disparity here that was the result of those industrial revolutions. So you know, the negative aspects are there, and I think if we identify those negative aspects and then plan different way of life in Sri Lanka, I think we can mitigate some of those.
Prasad, do you want to ask any questions? Prasad, are you there?
Hello, Chaminda. Can you hear me?
Yes, yes. Please go ahead.
Yes, because I am mute my mic because some noises here. Then I have some ideas. I think I want to time to think this technology. Then after that I can tell something.
Okay, if you come up with some ideas, please type in the chat box. Okay.
Okay, okay, I mean there.
Malmi, you want to add anything? I actually joined by giving up my slot to. If you have any questions, you can ask.
Can everyone hear me?
Yes.
Yes.
Okay. I have from what? Hello. Hello.
Yeah.
Yes, we can hear you.
Yes, we can
What
hear
I can
you.
think of is now from you. Yeah, from one company itself, we can do anything. Obviously, anything itself. So, what about the competition and also? What I meant is now we cannot have like duplicates. I mean, because what happens to the current industrial competition? Did you get my question?
The competition will always be there. Yeah, the competition should be there, and it will be there. Having a socially working enterprise like a fabrication lab should increase the company. I mean, we should have many labs, and then there will be other industries that produce things as well. We can always improve the quality of the products when you have the competition. So let's say we are making, for example, let's say we decided to make the LED bulbs in a fab lab in Sri Lanka, and there may be another company who produces the same LED bulb, and so now if the demand is not there, then whoever has the better product with the better price will win. That's how the current competition works. So the one with the better price and better product wins today, and that will still prevail even if you have these fabrication labs in Sri Lanka. And in the long time, these things might change, and if the society, if the community can come to the fab lab and produce it for their own consumption, then the demand will lose for that company, of course, and then the company will go bankrupt. Then that can happen, and I hope that happens, of course, in another 20, 30 years. But we don't know whether it will happen pretty soon. But if we have the infrastructure to produce things as a society, as a community, like local community, then we can stop buying things from companies, and that will be the end of companies. That's another disruption, as I see it, it's a positive way, but some people see it as a negative. Especially in US, they think it as a negative.
Tilan, with simple one A, can you ask any questions if you have? If you are around.
Okay.
Yeah, can you all hear me?
Yes.
Yeah. But I feel I have a doubt. You mentioned that we cannot recycle the things that we are going to produce using this 3D manufacturing. So how this will affect the environment, because we all are towards saving the environment, recycling and stuff like that. So how this will affect, and how what are the methods how we can overcome this kind of situation?
Yeah, what I meant was cannot recycle in the sense like cannot recycle very easily. Like we can recycle, of course, like just like when you have plastic bottles today, we can recycle them, right? When we produce plastic bottles and we recycle them, it's the same thing. But there's no easy way to do the recycling today. And then when you have these machines available to everybody, they will produce more. That's what I meant. The environmental impact means we'll be producing more, but then we don't have a easy mechanism to do the recycling today. But that, I think that's been seriously considered. Like, if we can, if the 3D printing machine itself can take the produced part and then recycle it within itself and then produce a new part, that's where we want to go, and that is not there yet. So we have to use the traditional recycling methods, and the volume of items to recycle will increase with the widespread with the spread of the technology. That's what I meant. There will be an environmental footprint when you have the capability to produce anything you think and you want in the future. Then there will be an environmental impact if we don't solve that the recycling issue within the technology itself. So that's what I meant.
Okay, I think we are kind of running out of time. So I would like maybe last question. Tilan has a question. Tilan from Maldives. Would you like to go ahead and ask the question? Tilan from Malay or island. He has asked a question.
Yeah.
What do you think?
Yes.
Yeah.
Actually, companies are deploying digital manufacturing because they want to, like, say, show their plants, like, say, virtual plant to us, and they want to identify the risks in planning upfront, not after building the plants and other thing. And like they want to like say provide the environment where workers can work effectively, efficiently, and those are the some kind of application where digital marketing come into play. But yeah, of course, the, manufacturing products, it's a one of the most important thing. But the, like say, identifying the risks, identify the plans, and identify the, like say, better, like say, improvements is one of the aspect of digital marketing. Will you be able to address if you put up a fab lab in Sri Lanka? Like say, my main concern is not the product. My main concern is the process.
What process you're talking about?
Like say, planning upfront and identify the risk and eliminate the risk, and like say ergonomics, the work study where people, what is the best way to people to work, and what is the orientation, and what is the best way to equipment to be placed and used, like that kind of thing. Because digital manufacturing is used, sometimes is used for that purposes.
Yeah. I mean, that's how it started. In fact, the digital manufacturing started as a rapid prototyping technology. To see the product before it is being sent to manufacturing, real manufacturing. So that way, you could reduce the risk. Of course, that's risk reduction, because you don't want to fail at the production site.
Yes.
If you know the product beforehand, then you can fix it in the design itself, and then basically you avoid the risk. And that's how it's being used quite widely today as well. And then and again ergonomics. Again, we can do the layouts of the of an office using 3D printed furniture and other stuff. And, we can arrange and see. I mean, the applications are enormous. That's so as as a risk avoidance for the risk avoidance, and also to improve the products and to improve the safety, and for the to produce much better products, and so on. So there are a lot of applications, of course, and you think of anything, you can do that. One another area, like for the energy crisis, with the 3D printed solar panels in the future, we will be able to solve one major issue with the energy crisis, especially in the southeast region, because we get a lot of sunlight in Sri Lanka, and if you can have solar panels available at a cheaper price, then that can provide a great solution for the current energy crisis in Sri Lanka, and so on. I mean, there is no end to the possibilities.
Okay, I think we are running out of time, so we want to finish the session very quickly now. But before that, I want to make a comment and also open for the next session of kind of comments from all of you. Now, I think based on the discussion we had today, now of course, now this digital manufacturing open new opportunities in terms of cost-effective, innovative products, access to market. There are a lot of opportunities, but then at the same time there will be also new challenges in terms of legal challenges, in terms of ethical, all other environmental challenges. Now, two things we have to remember. Now, any revolution, any innovation has losers and winners. So there will be some losers and there will be some winners, and that is why this the economist Schumpeter explain about the concept of creative destruction. Now, any creation, new creation, whether it's a computer, microchip, steam engine, they open with innovation, but it destroy what has been happening or what has been the norm in a particular time. So 3D printing and digital manufacturing will recreate or the rules you play in terms of supply chain management, how you distribute your goods and services. So there will be a lot of arranging processes. Now, I think it will take long time to go. Therefore, now when you are talking about something like digital printing in Sri Lankan context, we are not going to talk about rearranging or revamping everything what we are having now, but try some test or pilot test particularly in a situation where the current market mechanism or current distribution mechanisms have not worked. Maybe in a, I don't know, tsunami affected or poor community, or in a low affected area where you can use this 3D printing or digital manufacturing technologies to cater to those communities better, which is not being served by current market mechanism. Now, in that kind of context, what you think where we can, for example, now based on, of course, you can do your research and you can do additional studies. Now, do you think we can have some kind of, let's say, private project, as Greshan mentioned, if you have, let's say, funding and the expertise? Do you think we can do something like that in a small scale based on your expertise? Do you think it's viable, or if it is viable, what you as individual, as expert, can you contribute? Are you willing to do any contribution, or trying to share your expertise? Do you mind contributing your ideas, maybe starting from Buddhika?
Well, yes, of course. Yeah, it's something. I mean, first we need to narrow down what we are going to do, right? Because there may be a lot of avenues, but when we are implementing in Sri Lanka, we need to identify that what we are going to do. So, of course, like if somebody comes up with some sort of a program, then we can contribute based on our capacities.
Okay, thank you very much. Maybe Chintaka, any comments?
Yes, I hope you can hear me. Yes. Yeah, I think I liked what Greshan said about the social enterprise thing. That's one of the interested areas that I'm working on. So yes, I'd like to contribute if it's going to be such a social enterprise. I'm more than happy to share my time and expertise uh, to make the project successful. Anyway, thanks for sharing your expertise and ideas, and thanks for making us aware about the current situation with this digital manufacturing and all this. Thanks for your time. Thank you very much.
Okay, thank you, Chintaka. Malmi, you want to add something on whether you are interested in exploring more? Can you contribute if there are opportunities? What do you think it should be in Sri Lankan context? Anything?
Yeah, I mean, this is a very interesting discussion that I had. I was like really interested in 3D printing. So what I was initially thinking was, I have an
Dropping. We can't hear you.
I can like hello. Can you hear me now? Hello. Hello.
Yeah, go ahead.
Can you
Yeah.
hear me now?
Yes.
We can. I was initially thinking about the fashion industry. So anyway, we should start somewhere like from a very small point. So what I think is now the fashion industry would be an ideal fit for
Dropping away.
Sri Lanka and all. Hello? Hello?
Yeah.
Yes.
Hello? Okay. So I think
Yeah.
this is a very
Okay.
interesting. Thank you very much. Discussion.
Okay, Thilan, want to go? So, Thilan, do you like to say your final words before leaving?
Yeah, of course. This will be a great opportunity for Sri Lankan manufacturing industry, of course, because it is established industry where you can explore many opportunities. If you are planning to, like, say, invest on these things, of course, my support will be always there.
Okay,
Thank you very much.
Thank you for joining. I'll see you
Thank you.
again later. Okay, Prasad, you want to say something? Final words?
Yes, Chaminda. Actually, I must thanks for you and Greshan and all of you. I think we have to face some challenges, but we can do something in here. Then next time we can discuss major problems and other things. Actually, I hope to. Uh, I hope to discuss and I want to think this new technology how to use in here. Then finally I can't tell something, but I hope to join and do something. Okay,
Okay.
Chaminda, thank you.
Yeah, thank you very much. We actually want to get some new ideas. Only we have to continue discussing how to do and other details, but just to get some ideas. Priyanta, you want to comment about? I don't know your interest or what you learn or I don't know anything. Oh, your microphone is mute. We can't hear you. Unmute your mic.
All right. Now it's better, right?
Yeah.
Okay. No, we have to think of funding. So, and also probably we could start from the area of education because we have to promote this whole concept. of digital manufacturing. It's quite new pretty new, even for me, it's very new. And indeed, it's a very good idea to start a company here. I will be giving my best support.
Okay, thank you very much.
Thanks.
Tilan?
Hello?
Yeah, Tilan.
Hope everyone can, I think I would say that this is really interesting session. And I would like to thank Greshan and also Chaminda who facilitated this thing. And in future, I would like to say that I'm ready to contribute in my capacity, and please feel free to contact anytime, because this will be the next wave. This will be the future. So thanks again.
Thank you very much, Tilan. Umali?
Yeah, and first of all, I would like to thank Mr. Greshan and Chaminda sir to give this opportunity to participate to this session. And also, I would like to suggest that because this we heard about 3D printing, but I know that most of the people are not very much aware about the 3D printing in Sri Lanka. So if we can have an awareness session, and first, if we going for a project, I think it's more important to educate the people that what is 3D printing and is in the plus and minus both, and then we can go for a project. And of course, I would be there in my capacity when you need, and it's a pleasure for me also. Thank you, sir.
Thank you very much. Greshan, you want to conclude your thoughts? If you want to answer anything or say something?
Yeah, so yeah, once again, thank you to all of you for spending these 2 hours and especially listening to my idea about sparking an interest in Sri Lanka. That's the main objective. Now, sparking the interest is not easy, as you think. We cannot spark the interest by just having presentations like this, because if not everybody can attend this sort of presentation. To spark the interest, we need to do the real thing in Sri Lanka, and that's why I thought of having this establishing this lab in Sri Lanka. That way, people can see and feel and do things, and that's how I think we can spark the interest. Because if you spark the interest and make people knowledgeable about the technology, and I think that will have widespread implications in the future in Sri Lanka. So I heard that everybody would like to contribute in some way or the other. I think we need some good leaders in doing something like that. So that's where I think we need to look into next. I mean, if you guys are interested, I think we should have another session and see what level you can contribute. Like, I'm not talking about the money, but I'm talking about the knowledge, the amount of knowledge, and then the leadership and real labor that you can provide if you have a project like this in Sri Lanka. So I think that should be the next discussion. It should be sort of a planning discussion to understand how we can start, and what should be the focus areas, and what's the real revenue model, what's the real social entrepreneurship model, and so on. So I think I would like to ask Chaminda to organize another session towards that direction in 2 weeks, or however it is possible. So I think with that, again, thanks to all of you for your time and interest, and so hopefully we can continue this and make it successful, and we can make some changes in Sri Lanka for the better side, and avoiding we have to mitigate the negative aspects, and then do some good things to everybody. And at the same time, we can gain satisfaction by doing that. I know everybody here in this discussion, have gain a lot of have a good education and in a good position. But now we need to be able to collaborate for the greater satisfaction of our lives. So that's where I think we need to go as the next step.
Okay, thank you, Greshan. I think now, as we already discussed, now the idea of this session is to, Greshan used the term spark. So, in simple terms, it's like awareness building or letting people know, there is something like this. Of course, there are some people who are more informed than others, but now this is for anybody. Now, this video will be online from now onward. So, anybody can watch. I have already shared this among my social media networks, and of course you are also free to do so. This will be like our conceptual discussion where we have discussed about availability of the technology, how we should go ahead with that, maybe weaknesses, what are other issues we should think about, and also if anybody is interested, how we start maybe a pilot project. Now, that, as Greshan mentioned, we have to discuss in detail. Now, technology like Google Hangout is very useful in collaboration, global collaboration. Now, you look at the profile of people who are with us today, they are not simply God's children or just a collection of people. They are all experts on their own field, but now, based on my assessment, they are all, uh, capable people to contribute to a innovative technological project. That is why you are here. But at the same time, we should open this to other people. We need people who can question, the legitimacy of future concerns, how to go ahead, legal aspects, political aspect, public relations, community leaders. So all these things should be there because, as we already discussed, there can be a lot of unforeseeable or unforeseen issues. But I'm sure now, at least in a small scale, we can do a digital manufacturing as a community project, at least. So of course there will be competition, there will be copying by other people. That's still up okay because eventually the people of this country or even in this region benefit. So I would suggest that we can continue our discussion, have more interactions, can be online or maybe as Greshan mentioned by some kind of demonstration, or somebody can write something in a newspaper. You can explore more knowledge about what is written about this different experiences. Now I am actually planning to visit some places when I go some other countries, maybe in South Asia or in Europe. I'll visit these places and of course I'll share my expertise. So anybody has like final comments or anything about the session? You want to say something before closing? Overall impressions about the session? Anybody want to say something?
Yeah, so I'll be sending the presentation to everybody, or maybe Chaminda can send it, and then after that, go through it again, and then you may have questions later on. So contact me directly, or you can copy the entire group, of course, with the question. That way I can reply to everybody.
Public the presentation, can it be public a document? I can share it also in our network. Okay. Anybody want to talk anything about the session? General learning, interesting or boring? Very quickly. Malmi says it's highly knowledgeable, knowledge capturing session. Anybody want to say something? Okay, so yeah, thank you very much for your participation. It was really great to have you all. We are actually doing this kind of innovative, knowledge sharing in different subjects in different level. So this is one of such event, but it is actually very fruitful, and also interestingly there are no much technological problems. In fact, I'm now connected not with my normal 8 Mbps connection. This is 3G dongle. So I was very glad that we could continue till the end. So thank you very much, all of you. Good night to everybody except Greshan. Greshan is good morning, huh? And Greshan and Buddhika. So it's almost like just past midnight. So we will be in touch. And of course, among yourself, people who are connected, you can have your own collaborations. Thank you very much, and good night. So I'm going to stop broadcasting, and then if you want to say something private, that's also fine.